Hello everyone, welcome back to my math channel. Today we're going to be doing more of the 6th Cyprus Mathematical Olympiad. This is question number 20. In the diagram below, how many squares of any size are there whose entries add up to an even total? Alpha 12, beta 20, gamma 32, delta 36, or eta 45. Now, when you have any question like this, where you have consecutive numbers going in a row like that, then know this trick. If you have a single square, because the CYMS, the organization which made this paper, has used this once before as well in a different paper, which I have, and this is 1. Like here, the sum would be 1, of course. This is 2, the sum would be 2. So we already know all the numbers with even squaring will have the even sum because it's just themselves. But we're saying any size. So we can say 2 by 2. We can say 3 by 3. We can even say the whole square. And this is a 5 by 5 square, which will help us. Now the rule is, take a 2 by 2 square. It will be 1 plus 2 plus 6 plus 7. That would be 16. That works. And if we were to take another one, like 2, 3, 7, 8, 2, 3, 7, 8 are just these numbers, but they're all added by 1 respectively. Using this logic, we can then say that each and every single 2 by 2 square is the first square here that we highlighted, but it's added by a certain amount of 1s all of the terms. Meaning, if they're all added by 4 1s each and every single time, that's just plus 4, which means it's still even, because even plus even is even. So that means we can already deduce that all 2 by 2 squares are even. And then take a 3 by 3 square. A 3 by 3 square has a 2 by 2 square inside it. However, the rest of the squares are they can't form up another square. This is why we call the 3 by 3 squares odd. Have odd sums, because they don't form, they can't be made into equal 2 by 2 squares. However, if you'll notice, all even squares can be divided into 2 by 2 squares, of course, like here. This means that all even numbered squares, like 2 by 2, 4 by 4, 6 by 6, and so on, they're going to have an even sum in their numbers whenever you come up with a grid like this. And all odd squares, like 1 by 1, 5 by 5, and 3 by 3, they will have an odd sum, of course, and this is again only works in this type of grid, which has been used before in other questions. We can refer to these as the even squares and these as the odd squares. And so I explained to you what this trick is of the odd squares and the even squares, and when it says add up to an even total, we must know that we're talking about even squares. So we just want to know how many 2 by 2 squares there are, how many even 1 by 1 squares there are, and how many 4 by 4 squares there are. Simple enough, right? Because if we take here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You could also calculate it, but I'm just going to quickly count for now. And then here, when you get to the 2 by 2 squares, they look like this. And to calculate the 2 by 2 squares, we can find how many take up one side. And that would be 4 once we mark it up. So just then, if 4 2 by 2 squares per side, that would be on both sides. So we're just doing a 4 times 4, which is 16. So that's plus 16. Using the same logic, we can use this for the 4 by 4 squares, and only 2 fit per side. So this is going to be 2 times 2, which is 4. So it's 12 plus 16 plus 4, which is 32, giving us the answer gamma 32. I hope you enjoyed this video and learned something new. Please like, subscribe, and ring that notification bell for more videos like these. And also share this video to spread the knowledge. I'll see you then in the next video. Have a great day!